Macartney would have been there as usual, and I did want to find out more about their all-electric ELARS launch and recovery system they announced a couple of months ago. I chatted with their engineering director, Lasse Rasmussen, on the phone the other day, and he said it all came about as a response from electric ROV developers wanting to offer a more coherent electric package. Hydraulic systems have a high degree of energy density, but the fluid they contain is about 200 bar, probably more, and that pressure can easily leak. Now, if that happens on deck, they can contain it, but the A-frame spends a lot of time extended over the water, and if the hydraulics fails, the fluid may be discharged at high volume into the sea. So when they started to consider electric version, then they began to recognise a number of benefits. Hydraulic systems are notoriously demanding, requiring regular servicing, hydraulic oil needs to be periodically replaced, and hydraulic hoses must be pressure tested. They also need to spend time tracing and fixing leaks. It's quite labour intensive. The cost of maintenance and upkeep of the electric system, however, is probably 50% lower, they say. The energy consumption from electric LARs is also considerably lower than that of a similar hydraulic system. Electrical systems are also cheap to install. It's a lot easier to wire in an electrical system than to plumb in steel tubes back to where the hydraulic system is. Hydraulic systems are based on large cylinders and other equipment items, and these can have lead times of maybe 10 to 20 weeks, so spares need to be stored as protection against downtime, with all the expense that entails. Spare parts of electrical systems are much more readily available throughout the world. In electrical systems, the signals can be data logged, and performance software can inform the operator which motor or which part of the motor will need attention and when. Macartney are reticent to disclose the system details, but they have made big efforts to incorporate as much proven technology as possible. Lasse said that the offshore industry is well known for being conservative, and hydraulic systems have been available for years, so going full electric requires a huge change of mindset. He said, however, that their subsystems are based on technologies that they've used for 20 years, so they have a high level of confidence. Electrical systems are more controllable and fit in well with the design thinking of the latest generation of unmanned ships. They have a high level of automation, and this opens up the next level of intelligent solutions. If a hydraulic system on an unmanned vessel leaks, then the power and control fails and it has to return to port. In electrical systems, however, this is far from the case. Macartney's design has built-in redundancy, so if one of the drive motors fails within the frame, the system can still operate. I mean, they even have incorporated emergency recovery modes so that even if the PLC breaks down, there's still a way of retrieving the ROV in emergency. If you want to know more about subsea engineering, read UT2 or UT3, the online version. And if you want to see more about what would have been happening at Oceanology, look at the next vid.